Good morning, grade 12. Today's lesson is about the sum of a geometrical series. Now you can remember that in order to calculate a certain term in a geometrical sequence, we use this formula. Let's use this formula again just to see in a general geometrical sequence what the terms will be. So if we substitute n with 1 and we determine term 1, we will get a times r to the power of 1 minus 1, which is 0, and that something to the power of 0 is 1. So a times 1 will be a. And that is true. Term 1 is a. Let's look at term 2. Now we substitute 2 into n's place. So it will be a times r to the power of 2 minus 1, and that is 1. And this will give us a r. If we do it with term 3, it will be a times r to the power of 3 minus 1 is 2. So we have a r squared. If we look at the nth term, it will be a times r to the power of n minus 1. And we get a r n minus 1. What will happen to the term just before n? That will be term n minus 1. So now I need to substitute n minus 1 into n's place. And you'll get a to the power of n minus 1 minus 1. And that will be a to the power of a r to the power of n minus 2. And this is important for the proof of the sum of the geometrical series formula. So let's look at the proof. We need to calculate the sum of all of these terms until term n. So we start with a plus ar plus ar squared plus, carry on, ar to the power of, if this one is n minus 1 and the one before that is n minus 2, the one before this one will be n minus 3 plus ar to the power of n minus 2 plus ar to the power of n minus 1. And let's name this equation 1. Our next step in the proof is to multiply each of these terms again with r. So I'm going to take number 1 and I'm going to multiply it with r, the ratio. So here we will get r Sn equals a times r will give you ar. So just to be clever, I'm going to write it below the ar. Plus, if you take ar and you multiply it with r, you will get ar squared, etc. Now if we take this one, this term, and we multiply it with r, we will get, okay, let me do this on a separate page, ar to the power of n minus 3 times r. the exponent of r will be 1. And you can remember from the exponential laws that if the bases are the same, you can just add the exponents. So I have a r to the power of n minus 3 plus 1. And this will be a times r to the power of n minus 3 plus 1 will give you minus 2. So if I multiply this with r, I will get a similar answer to that one. So it's a r n minus 2. Now I'm going to take this term and multiply that one with r. A r to the power of n minus 2 times r will be a r to the power of n minus 2. Because the r has the same base, we add the exponents. And we have a r to the power of n minus 2 plus 1 gives me minus 1. A r to the power of n minus 1. Now I'm going to take the last term and multiply it with r. So it's a r to the power of n minus 1 multiply with r. And we get a times r to the power of n minus 1 plus 1. And this will give us a times r to the power of n minus 1 plus 1 is 0. So I just add here a r to the power of n. And this will be equation number 2. Our next step in the proof of the sum formula is to subtract 1 from 2. So I'm going to take number 2 and I'm going to subtract number 1. Or Sn minus Sn will be on the left hand side. Here we have a 0 plus. So 0 minus a will give me a minus a, negative a. AR minus AR is 0. AR squared minus AR squared is 0. The same here and here, but here I have a last term. AR to the power of n minus nothing. So I'm left with AR to the power of n. On the left hand side, I can take Sn out as a common factor. And in the bracket remains r minus 1. Let's just shuffle that. So it's AR to the power of n minus a. In this case, I can take a out as a common factor, and I have a bracket r to the power of n minus 1. But I want Sn alone. So I should divide here with r minus 1, and what I do on the left hand side, I must also do on the right hand side. Then these cancel out, and you are left with Sn equals a times r to the power of n minus 1 over r minus 1. And that is the proof for the sum formula of n terms in a geometric series. If we look at example E on page 2 of your notes, they give us a geometrical sequence. Remember, sequences have semicolons and series have pluses. Now they ask us, calculate the sum of the first 3 terms. It's always good practice to write down what you have and what you want. Calculate the sum, so we are going to need the Sn of this sequence of the first 3 terms. So we only need to calculate the sum of 3 terms. In this case, n will therefore be 3. Now if you look at that geometrical sequence, they already told us it's geometrical, so we know we have a ratio. We divide term 2 with term 1 and we get an answer of 2. Let's check if this one is the same. Minus 8 divided by minus 4 also gives me 2. Therefore, R, the ratio, is 2. And I can see that A is minus 2. We know it's a geometrical series or sequence. So we can use the sum formula for the geometrical series and sequences. And that is A times R to the power of n minus 1 over R minus 1. And now we can just substitute all the values. A is minus 2, R is 2, n is 3, minus 1, over R is 2 minus 1. And if you type that into your calculator, you will get minus 14. When you substitute n as 3, remember to write your S as the sum of 3 terms. So the sum of 3 terms is minus 14. You could also have done this mentally. They want the sum of the first 3 terms, so it's minus 2 plus minus 4, that's minus 6. Minus 6 plus minus 8 is minus 14. The next example I want to do with you is example 3 on page 24 in your textbooks. In the first question, they ask us to calculate the sum of the geometrical series. They give us the series and they want us to calculate the sum up until 10 terms. So before we can start, let's quickly see what the ratio is. How do I know that there will be a ratio? Because they tell us it's a geometrical series. So it's 4 divided by 2, and that is 2. 8 divided by 4 is 2. So my ratio is 2. Okay, let's write down all the things that we have. We know it's a geometrical series. We have to calculate the sum, so we're going to need the sum formula. Up till 10 terms, so n will be 10. We have A, it's 2, and we have R, it's 2. Because it's a geometrical series, we're going to use the geometrical series formula. And now we substitute the n with 10, the A with 2, the R with 2, the N with 10, the R with 2 minus 1. You can type this in to your calculator and then you'll get the answer of 2046. So the sum of the first 10 terms will be equal to 2046. Question number 2, they ask us to calculate the number of terms in a geometrical series if you add the series up until the nth term, and the answer will be 3069. So what they actually give you is this clue undercover. Sn will be 3069. So let's write down what we have. We have that we need to calculate the number of terms. They give us the sum of those terms. They tell us it's a geometrical series. We know A is 3, and we can work out R. 6 divided by 3 is 2, 12 divided by 6 is 2. So my R, my ratio, will be 2. The sum of a geometrical series formula is A times R to the power of n minus 1 over R minus 1. Sn has a value of 3069, so I can write it here. A is 3, R is 2, I have to work out the n, here must be a 2, minus 1, over, R is 2, minus 1. Let's simplify. 3 times 2 to the power of n minus 1. 2 minus 1 is 1. Okay, in order to get n alone, I have to get rid of this 3 first. The 3 is multiplied with the bracket, so the inverse operation will be to divide by 3, but you have to do it on both sides. This divided by 3 gives me 1023. The 3's cancel out and you are left with 2 to the power of n minus 1. Now we're going to take the minus 1 over to the left hand side, so it becomes a plus 1. And you get 1024 equals 2 to the power of n. I need to rewrite this number as a base of 2, and 1024 is 2 to the power of 10. When you have an equation with the same basis on both sides, you can take them away and n will be 10. Therefore, the sum of 10 terms will give you the answer of 3069. In example number 4, they give us a geometrical series sum formula. When you get a question like this one, where they give you a sum formula, there's a certain way to do that, and I'm going to show you. If we take, for instance, let me just get another paper. Term number 1, term number 2 and term number 3. Let's say it's 2 plus 4 plus 8. So the sum of the first term will be 2. You only need to add the first term to get the sum of the first term. And this is also the same as T1. Let's work out the sum of the first two terms. 4 plus 2. That is 6. The sum of three terms will be 2 plus 4 plus 8, and that is 14. Right. Let me write it there. The sum of one term will be 2. The sum of two terms will be 6. And the sum of three terms will be 14. Now, if I want to get the value of term 2 by looking at these sums, you can say it's the sum of two terms minus the sum of one term will give you term 2's value. The same apply here. To get term 3's value, I can say it will be the sum of three terms minus the sum of two terms. Then you'll get term 8, the value of term 3. So let's write it here. So term 2 will be the sum of two terms minus the sum of one term. And term 3 will be the sum of three terms minus the sum of two terms. And this is a very important trick or technique to work out questions where they give you a geometrical series sum formula. Okay, so let's just generalize this one. Therefore, if you have term n, you want term n, and you only have the sum of all the terms, it will be equal to Sn minus the sum of the previous one. The previous one of n will be n minus 1. So in order to get a certain term, when you only know the sum answers, you take the same sum of that term and you minus the sum of the previous terms from this one. This is very handy. Now let's look at our question. Calculate term 1. Term 1 will be the sum of term 1 minus the sum of the previous one. We don't have a term, the sum of no terms. So term 1 will be the S of 1. So let's substitute 1 into that one. So it will be 64 minus 2 to the power of 6 minus n is 1 minus nothing. So the sum of no terms will be nothing. And if you work this out, term 1 will be 32. Question B. Work out term 12. We use the same handy trick. it will be the sum of 12 terms minus the sum of 11 terms. So let's substitute n as 12 into our given formula. 64 minus 2 to the power of 6 minus 12 minus. Now we want to substitute 11 into n. So it's 64 minus 2 to the power of 6 minus 11. And if you type that into your calculator, you will get an answer of 1/64. Question C. Calculate the first 3 terms. We know term 1 is 32. Let's calculate term 2. Term 2 will be the sum of 2 terms minus the sum of 1 term. We substitute 2 into n's place in the given formula. So it will be 64 minus 2 to the power of 6 minus 2 minus. The sum of 1 term is the same as term 1, and we know term 1 is 32. Type that into your calculator and you get an answer of 16. So we have term 1 is 32, term 2 is 16. We know that it's a geometrical series, so we have to get a ratio. A ratio is we divide 16 divided by 32 gives me a half. So my R is a half. What can I do with that half? 32 times a half will give me 16. So in order to get term 3, I must say 16 times a half, and that will give me 8. There is my first 3 terms. So what did I do? I said term 3 will be term 2 times R. Term 2 is 16. My R is a half. 16 times a half gives me 8.